Hello class, this is Mr. Eggleston and this is lesson 6.6, Power Functions for Algebra 1. The learning targets of this is, the first one is identify functions as power functions and determine the degree. And then the second learning target is to compare the growth rates, which is kind of a higher end concept, of power functions as it relates to the degree of the function. All right, first of all, what is a power function? I'm just going to go ahead and front load this. Power functions look like this. F of x equals 2x to the third power. That's a power function. It has a real coefficient. Coefficient is just a fancy word for the number in front of the variable. And an integer actually I should say a whole number because it's positive, and a whole number exponent. Okay. So that's a power function. Here's another power function. Okay. Here's a third power function. What is not a power function? Would be things that look like this. W of x equals 2 to the power of x. R of x equals 3 over x, something like that, which could also be written as 3x to the negative 1. Those are not power functions. All right? And there you go. All right, so here it goes. It says, Mrs. Gaius' 2-year-old son, Owen, loves to build with blocks. At first, she thinks he's just building for fun, but now she wonders if maybe he's a mathematical genius. All parents think their kids are mathematical geniuses. I thought my daughter was a mathematical genius. She's a pretty bright kid, but mathematical genius? No. It didn't work out for her in that way. All right, so Owen's first structure is a cube with side lengths of 2 units. So this is 1, 2, 1, 2, and let's see, 1, 2. All right. What is the area of one of the faces of the cube? Well, the one face of the cube is a 2 by 2 square. So the area would be 2 times 2, which is 4, which happens to be 2 to the second power. What is the combined area of all faces of the entire cube? Of all faces, that's referred to as a surface area, so I'll use SA. That would be 6 times 4, which is 24. How many blocks did it take to build the cube? Blocks, that's the volume. So they're asking you for the volume, and the volume is going to be length times width times height. They're all 2. Okay? So that's 2 times 2 times 2, which happens to be 2 to the third power, which is 8. Now, Owen's next cube has side lengths of 5. So this is 5, that's 5, and that's 5. All right, 3 dimensionals, 3 lengths, all 5. What is the area of one of the faces of the cube? So the area is just going to be 5 times 5, which is 25, which happens to be 5 to the second power. What is the combined area of all faces? Remember, there's 6 sides to a cube. So the surface area equals 6 times 5 squared, which is 6 times 25, which happens to be 150. Okay. How many blocks did it take to build the cube? Well, that's the volume. And that's going to be length times width times height, and that's going to be 5 times 5 times 5, or 5 to the third, which equals 125. Okay? Then it asks you to make a table from what we've done. So the area, if you had side length of 1, the area of a face would be 1 squared, or 1. If the side length was 2, the area of a face would be 2 squared, which was 4. If it was side length of 3, it would be 3 squared, which is 9, and 4 would be 4 squared, which is 16, 5 squared, which is 25, and 6 squared, which is 36. The surface area is just 6 times the face area, or the area of the face, so that would be 6 times 1, which is 6, 6 times 4, which is 24, 6 times 9, which is 54, 6 times 16, which is 1696. I'm doing this in my head. 6 times 25, which is 120, 150. And 6 times 6, or 6 times 36, will be whatever 6 times 36, it was at 216, I think. All right, and by the way, 216 is my favorite number because it's 6 times 36, which happens to be 6 times 6 times 6, or 666. Scary. All right, and the volume is just going to be, for a side length of 1, will be 1 to the third power, which is 1. For a side length of 2, it'll be 2 to the third power, which is 8. Not 6, 8. For a side length of 3, that'll be 3 to the third power, which is 27. 4 to the third power is going to be whatever 4 to the third power is. Getting my calculator out on my phone. 4 times 16 is 64. 5 to the third power is going to be 125, and 6 to the third power is going to be 216, which is the same as the surface area of side length 6, just because there's 6 sides to a cube. It wasn't a cube. If it was another thing that had a different number of sides, then it wouldn't be 216. Write an expression for the area of one face using the side length of a cube S. Well, if you look at that, it's all squared, so the area is going to be side squared. Write an expression for the surface area of a cube. SA, since there's 6 sides, 6 times S squared. Write an expression for the volume. That's just going to be side to the third power. Which grows fastest, the area of one face, the surface area, or the volume? Why do you think that? Well, the volume grows fastest because we multiply by S one more time. Then than area, right? S squared, one more time. Area equals S squared, volume equals S to the third. Okay? Right here, this is a power function. These are all power functions. So these are all power functions. Okay. This is degree 2. This is degree 2. This is degree 3. Because the degree is dictated by the power on the variable. Okay. So in the end, the power function with the highest power grows fastest. Dot, dot, dot. If degree, which is the highest power, degree is the same, the function with the largest coefficient grows fastest. And there you go. Easy peasy, nice and easy. All right. Have a good one. I'll come back with the solutions to the CYU. Check your understanding. Actually, let me do this. Let me do the quick notes. Learning target number 1, power function. A single term that is a real number, which we call a coefficient, multiplied by a variable with a real number exponent. The degree of the function is the value of the exponent. So, as you can see, these are all examples. 2 times x, 8 times x to the 5th, x to the 2, real number exponent, x to the 2/3, x to the -4. All right? Non-examples are things like x squared plus x, because that has 2 terms, or 3 to the x, which is the reverse of what we want. We want x to the 3rd, not 3 to the x. Okay, power function growth. Power functions with greater degrees grow faster than power functions with lower degrees. If the degree is the same, look at the coefficient to compare. All right? And that's it. And then I'll come back for the check your understanding in a different video.